Hi everyone, in this video I will going to solve this algebraic equation. The equation we have mn is equals to 1 and m plus n is equals to 1. Here we need to find out the value of m and n. So let's get start the solution. This I will going to name as 1 and this as 2 equation. Now first I will going to take equation 2 here, that is m plus n is equals to 1. Now I'm going to make subject of n here. So I'm going to take this m to the right hand side. So 1 minus m. So this is our equation 3. Next I'm going to take equation 1. Mn is equals to 1. Now in replacement of n, I'm going to plug in equation 3. M times 1 minus m is equals to 1. And this will turn to m minus m square is equals to 1. Now I'm going to rearrange and now I'm going to take this 1 to the left hand side. So minus m square plus m minus 1 is equals to 0. Now here we have the negative sign. So for that I'm going to multiply both the side by minus 1. Here this will turn to positive m square minus plus minus m and minus plus 1 is equals to 0. Now here we get the quadratic equation. Now I'm going to find out the value of m by using the quadratic formula. So here we have the coefficient a we have that is 1 and b we have negative 1 and c we have positive 1. And the formula we have that is m is equals to minus b plus minus root of b square minus 4ac over 2a. Now I'm going to plug in the ABC's value here. M is equals to B value we have negative 1 plus minus root negative 1 whole to the power of 2 minus 4, and A value we have positive 1 and C we have positive 1 over 2 and 1. This will turn to positive 1 plus minus root negative 1 whole to the power of 2 is equals to positive 1, and we have minus 4 over 2. And this will turn to 1 plus minus root negative 3 over 2. Now from this negative 3, I'm going to separate this negative sign. I'm going to write m is equals to 1 plus minus root 3 times negative 1 over 2. Now here I'm going to apply the radical rule, that is n root of a times b can be written as n root of a times n root of b. So here I'm going to write this both value in separate root. M is equals to 1 plus minus root of 3 times root of negative 1 over 2. And this root of negative 1 is always equals to iota, the imaginary number. I'm going to write m is equals to 1 plus minus root of 3 iota over 2. So here we get the two m values. First one is positive 1 plus root of 3 iota over 2, and the other one we have 1 minus root of 3 iota over 2. So here we get the two m values. Now I'm going to find out the value of n by using this m1 and m2 value. So for that I'm going to take equation 3. N is equals to 1 minus m, where I'm going to find out the value of n1. For that, I'm going to use m1 value here. n1 is equals to 1 minus, and here I'm going to plug in 1 plus root of 3 iota, and this 2 I'm going to add it both the numerator here. So here we have the negative signs. I'm going to put this in the bracket and solve it out further. Minus 1 over 2 minus plus minus root of 3 iota over 2. Now I'm going to take here LCM. So here we get 2 and 2 minus 1 minus root of 3 iota over 2. And here we get the n1 value, that is 1 over 2 minus root of 3 iota over 2. So here we get the complex solution for n1 and m1. Now I'm going to use equation 3 for finding out the value of m2 by using the value of m2. Now here I'm going to plug in the m2 value, that is 1 over 2 minus root of 3 iota over 2. I'm going to solve it out this by multiplying this negative sign. So this will turn to n2 value we have minus 1 over 2 and minus 1 is plus root of 3 iota over 2. Now here I'm going to take LCM. So here we'll get 2 and 2 minus 1 plus root of 3 iota over 2. So the value of n2 we get here, that is 1 over 2 positive root of 3. So here we get another complex solution. Now I'm going to verify my answer. I'm going to take equation 2 here. M plus n is equals to 1. And here I'm going to verify my m1 and m1 value. So the value of m1 we have, that is 1 over 2 and plus root of 3 iota over 2 plus 1 over 2 minus root of 3 iota over 2 is equals to 1. Here this positive 1 and this negative 1 going to be cancelling out. So here we'll get 1 over 2 plus 1 over 2 is equals to 1. And here we have the common denominator. So I'm going to add up the numerator 2 over 2 is equals to 1. So the left hand side equal to the right hand side. So the value of m1 and n1 is also absolutely correct. I'm going to verify my m2 and 2 value by using equation 1. The equation 1 we have mn is equals to 1. And here I'm going to find m2 value. I'm going to plug in the m2 value first. That is 1 over 2 minus root of 3 iota over 2. And this will going to be multiply 1 over 2 plus root of 3 iota over 2 is equals to 1. Now here I'm going to apply the algebraic identity, that is a minus b. A plus b can be written as a square minus b square. So this is our a value here and this is our b. So this can be written as 1 over 2 whole to the power of 2 minus root of 3 iota over 2 whole to the power of 2 is equals to 1. Now this will turn to 1 over 4 minus this root of 3 whole to the power of 2 times iota square over 2 to the power of 2 is equals to 1. Here this and this get cancelled and root of -1 is equals to I here. Iota square will be equals to, so I'm going to take square both the side. And here this and this get cancelled. So the iota square is equals to -1. I'm going to plug in the value of iota square as -1. So this will turn to 1 over 4 minus 3 -1 over 4 is equals to 1. I'm going to solve it out. 1 over 4 minus and minus going to be changed to plus, and here 3 over 4 is equals to 1. Now here we have the common denominators. I'm going to add up the numerator, 4 over 4. So the left hand side equal to the right hand side. So the value of M2 is also absolutely correct. Thank you so very much for watching my video. If you like my video, please do hit the like button and please support my channel by subscribing it.